fractions, so fractions with algebra in them, and the first skill is to simplify them. So what we're going to try and do is have something on top and bottom which can cancel each other out and therefore make it more simple. Now the classic error is people go, oh look, there's an x squared and an x squared, we can cancel them, but this is division, and the inverse of division, which allows us to cancel, is multiplication. But this x squared is not being multiplied by these, it's being added to it. So that adding and division is not the inverse, so we cannot simplify yet. So with most things in algebra, if you get stuck or get to a certain point, you have to think about writing it in equivalent ways, which is what we call factorizing in this case. So there is nothing common to either of these terms, so I know it must be a double bracket. It's 1x squared, so I know it's an x and an x. So what are the factors of 6? I can make 1 from. So that must be 3 and 2. So I put a 3 there and I put a 2 there. So how do I make a 1 from 3 and 2? Well, it's plus 3, take away 2. And we'll do the same on the bottom, but what I'm expecting is one of these to be the same. And I can tell you it's this straight away, but I'll tell you why I did that in a minute. So this is a factor of 10 that makes 7. So the only factors of 10 are 10 and 1, can't make 7, and 5 and 2. And because I saw that and I knew it had to be one of these, 10 is not in the 3 times table, and 10 is in the 2 times table. So I know it's 2 and 5. I know that has to be a minus because I'm looking for one to be the same, but let's just check. How do I make minus 7x from 2x and 5x? Well, minusing both. And just to check, the constant terms multiplied together will be a positive 10. So they cancel out, and I would rewrite my answer, so x plus 3 over x minus 5. Now you'll see this next one, this has a coefficient of x squared, so potentially very difficult. Especially if you're doing the normal one, you'd be writing factors of 30, lots of different combinations. But always look, because top might be easier, or in some cases the bottom might be easier. So the top one is actually right. So it's a normal one, just like we did before. So factors of 15, so 3 and 5, or 15 and 1. Has to be 3 and the 5 to make the 8, and they both have to be minus. Which means, in this bottom part, one of the brackets has to be the same. Now, because this is prime, the only option is 2 times 1. So 1 has to be 2x, 1 has to be x. Now, it's factors of 15, so it's 15 and 1 or 5 and 3. So I know it can't be 15 and 1 because I have to use one of these. So it's whether this is the 3 or whether this one is the 5. So I'm going to do a bit of trial and error. So I'm just going to, let's imagine, well, I'll write it small. Let's imagine there's a 3 there and a 5 there. That would give me 6x and that would give me 5x. So I know this isn't right because using the 6x and a 5x, there's no way I can make a 7. So that must be the 5 and that must be the 3. That's 10x and that's 3x. So if I have minus 10x plus a 3x, it works. And I could have said, well, if that's the 5, it has to be a minus because they have to match. I have to have the same in top and bottom. See? Multiplied, divided, so they cancel each other out. So if you haven't quite followed that, it doesn't matter if you know a way of factorising this. So just factorise it normally, factorise that normally, and you will always get something the same if you've done it correct. Now this one looks a little bit different, and if you look at the bottom one, there is something common to both terms, and that's a 2. So we have that. So we know at some point up here we have to have this bracket. Now this doesn't look like these, and this is because this one is the difference between two squares. You can always spot it because there's a square number and no middle term. So essentially, because there's nothing common, it has to be double brackets, has to be a p and a p, and it's factors of 9 that make no p's, so it has to be 3 and 3. And if we have a positive 3 and a negative 3, we can cancel these out and therefore get p minus 3 over 2. So you have to be good at factorising and maybe make sure you've mastered that skill before you even bothering with these. Let's look at this one. So once again, this one looks a little bit different. The top looks nice to me because there's something common to both, and that's a 3x. So I can take out a 2 to make, well, put in a 2 to make 6, and another x to make 6x squared. This bit's a bit tricky, but it has to be a 1. So if you factorise this bit correctly, you should know that somewhere in here there is going to be this. Now there's nothing common, so I know it's a double bracket. And again, just like before, this is a difference between two squares because they're both square numbers. And if you know that, you know the bracket has to be the same but with a negative. But watch, 4x squared minus 2x plus 2x is no x's, and minus 1. So they cancel each other out, and we are left with that. Now this one is actually the easiest, but can often catch people out because there is no factorising involved. How many 3's go into 6? Well, 1 3 goes into 3, and 2 3's go into 6. And we've got a w divided by a w squared. If you think about your indices, like that would be 1 take away 2, so it'd be minus 1. So, in fact, I'm going to rewrite this because it definitely makes more sense to you this way. Okay, so I've changed the numbers to 2 and 1, but so there's 2. There's no s squareds on this side, but that take away that would be this, and that's it. You could write this slightly differently. You could write it like this. That's the same thing because that one would cancel out that one. So it is actually quite complicated. I prefer the other ones, but there you have it.